So this is what we call interval notation. And so the main concept that we're going to learn is how to use interval notation We're going to use it to identify domain, range, and other intervals. Okay, so the first thing we're going to do is something you already know how to do. You've been doing this since probably 6th grade or so, where they give you a number line, and they give you, over here I've got these inequalities, and I just need to graph them. So we just need to be reminded of a few things. So they gave you a little reminder right here. If I have x is less than 3, and I want to graph that on this number line, what should I do? Put a dot on the 3. What kind of dot?
Hollow.
Hollow dot. An open dot on 3. Is everybody good so far? Anybody have a question about why it's an open dot? We're all okay? Alright, and now what?
Draw a line.
Shade to the left, right? So I'm going to shade this way. I am shading to the left because this is a less than sign. And as long as the x is on the left, like it is over here, that little arrow shows you which way to shade. It points to the left, so I shade to the left. Or I can read it, x is less than 3, less than shades left, because they both start with L, so less than shades left. Or you can just remember, where are the numbers that are less than 3? They would be to the left of 3. Whatever helps you remember, that's fine. So this is all old. So let's do the same thing for the next one. I've got x is greater than or equal to -2.
Solid dot.
Very good. Solid dot on -2. Shade to the right. We are shading to the right because the little arrow points to the right, tells me to shade that way. And also because it is not a less than sign, it's a greater than sign. So I can't shade left because it doesn't start with an L. And because the numbers that are greater than -2 are to the right of -2. Alright? So next one. This is what we call a compound inequality. It has 2 values, 2 signs, which means I'm going to have 2 dots. Alright, so I need a dot on -1. What kind?
Hollow.
Hollow open dot on -1. What about the one on 5?
Solid.
Solid. Shade in between the 2 dots. Alright. And then the last one on the page. I have a solid on -4. Solid on 0. Shade in between. Alright, so that should have all been a review of stuff you already know. So now, this is the notation we've been using over here on the left. It's algebraic notation, or sometimes they'll call it inequality notation. So that's what we've been using, but sometimes it can be kind of confusing. Because when we're using it to identify domain and range, we have to throw in those curly cues and the sets and all that stuff. Interval notation is a little bit simpler. You don't have to do that. What you have to do is, just like we've done before, we're going to read this like we've been reading domain. How far left is this red graph going to go? Infinity. So with interval notation, I write that down. It is going to, now, it's going to the left. So we have to indicate that it's going to the left, so we say negative infinity. It's a sideways figure 8. If you can't draw a sideways figure 8, just draw 2 circles next to each other. because I know what you mean. How far right is this going to go? To 3. So I'm going to put a 3. Now, in order to indicate that it is an interval and it touches everything in between, I put a comma. Now, the only other thing we have to do is we have to identify what kind of circles these are. And just like open circles go with these signs with no equals underneath, in interval notation, parentheses go with those. So this 3 is an open circle, so it has to be a parentheses. It's what we call unbounded. So it's got a parentheses on it. Now, negative infinity, it also has to be unbounded because infinity can't be bound at all. Because what happens once you get to infinity? It keeps going, right? You get to where you think infinity is, and it's further and further and further. So it can't be bounded either. So anytime you have an infinity symbol, whether it's a regular infinity symbol or a negative infinity, it's going to be a parenthesis. Okay, so now let's look at the pink one. Always asking how far left, then how far right. So how far left is this going to go?
Negative 2.
-2. How far right?
Infinity.
Infinity. This time it's a positive infinity. I already know that infinity is unbounded, so that's going to be a parentheses. When you have solid dots, like what we have on -2, we have to indicate that by using brackets. So this is going to be a bracket, -2 to infinity, parentheses. Okay, so let's check the blue. How far left does it go? -1. How far right? 5. The -1 is an open circle, so that would be unbounded. That's a parentheses. 5 is solid, so it's a bracket. Last one, purple. -4 to 0. Both of them are brackets because they're both solid dots. They're what we call included in the answer because it actually touches -4, so -4 is included. That's why we put a bracket. All right, so let me give you a few little things to remember about interval notation. So that's it. Like, how easy is that? So interval notation, first thing you need to remember, open dots have parentheses. Closed dots have brackets. Infinity, always parentheses. And the last thing, and this is the only catch to this whole thing. Interval notation can't be used for discrete data. That's why it's called interval notation. It's telling you it covers an interval. So it can't be used for individual points. Unfortunately, because it is so much easier. All right, so let's look at one, top of the page. This time they gave you the interval. Now look, here's where you have to be a little careful. What does that first thing look like?
Point.
Yeah, like just an ordered pair, right? It just looks like a point. The reason I know that it's not is number 1, because we're in a worksheet called interval notation, but number 2, all they gave me was a number line. So I can't have an x and a y-axis, all I have is x. So that can't be an ordered pair. So it's an interval. So take a second and draw those 3, and then I'll put them up and see if you get them. top one's got two open circles, one on -2, one on 3, shaded in the middle. Middle one, it's negative infinity to 1, solid dot on 1. And then the last one is open dot on -4, shade right to infinity. Is everybody good? All right, so now let's talk about if you've got more than one piece. So these are some more compound inequalities. These happen to be OR inequalities. So I'm going to shade each of them, each piece, and then we'll talk about the notation. So got an open circle on -3. It's pointing left, so I'm shading left. And then open circle, closed circle on -1, shade to the right. Okay, so now.
If it's supposed to be open or,
By what, okay, I'm glad you asked, because whether or not it has a line underneath.
something.
And the way I've always thought about it is it takes more ink, so especially if I use dry erase markers, like this doesn't take very much ink and neither does this. But this is a little bit more ink, so I have to use a little more ink on my circle. Does that make sense? That's how I keep it straight. Okay. And same thing if when you get into boundary lines, so this is a dotted line because it uses less ink, and this is a solid line because it uses more ink. Alright, so on this piece, when you look at the graph, there's actually two pieces of separate graph. So there's going to be two pieces of separate notation. One that represents the left piece and one that represents the right. So on the left, it's going negative infinity to -3. Negative infinity has to have a parentheses, and so does -3 because it's an open circle. Then leave a space. The next one is a bracket, -1 to infinity. Infinity is always a parentheses, so. Now, even though they look like two separate pieces, they're actually two pieces of the same graph. So you have to notate that in your interval notation with a big fat U. It's kind of a funny shaped U. And that U means in union with. This first piece is in union with the second piece. They are together as one graph, even though they look like separate pieces. Okay, so you try the one underneath it. I haven't heard it. Case, I've got my left piece goes negative infinity to -2, solid dot because it had a line underneath it, so it's equal to, so solid dot. The next one has 0 and 3.5. 0 is an open dot because there's no line underneath. The 3.5 is a closed dot because there is a line underneath and you shade between. So if I'm going to write this in interval notation, I've got to do two separate pieces, the one on the left first. So it's negative infinity, so that's a parentheses, to -2 bracket, because it's a solid dot, in union with the next piece, which is parentheses, because it's an open, 0, 3.5 bracket. Okay? Alright, we're going to skip these for right now. You already know how to solve inequalities, and we do a little bit more of it in a couple weeks, so we're not solving them now. We're going to look at these and do domain and range. Write them in interval notation. So, now the only other thing about interval notation is there are no x's and y's in the notation. So there's no way for me to know whether your interval is representing domain or range. So you have to clarify for me. So on this one, let's do domain first. So I'm just going to put a D and a colon before I write the interval notation. So I know which one is domain and which one's range. So remember, domain, you always ask yourself, how far left does this graph go? And how far right does it go? How far left does it go? -5. Should this be a parentheses or a bracket? Bracket. -5, comma, how far right is it going to go? Infinity. Parentheses. Range, you always ask yourself how far down first, because you got to make sure you got the smallest numbers first. So how far down? -3, bracket, because it's a solid dot. How far up? Infinity. And that's it. Easy enough. Okay, so on the next one, let's do domain first. How far left, how far right? How far left? Bracket -6, how far right? 4, parentheses, because it's an open dot. Okay, so now on range, how far down, how far up? So when you look at how far down, it goes down to -3, and even though they did not write them as solid dots, the graph actually touches right here at -3. So it is a bracket. And it goes all the way up to 7, and that is also a bracket, because right up here there's an actual point where it touches there at 7. Y'all good? Alright, this one's a little strange, because it's all one piece, sort of. It's really two pieces, because this right here is a hole. So it goes from there to here, stops for just a second, and starts over again. So when you write this one, you should have two pieces. So my domain, how far left does it go? -infinity to 4, parentheses, because it's an open dot. In union with, because right after 4 it starts over again, 4 to infinity. The range also goes to -infinity up to -1. It's an open dot, so it's a parentheses, in union with -1 to infinity. Okay, so I personally like this better, but if you like the other method better, that's okay too. You can use it. I don't care. You need to be able to read and understand both of them, but you can use whichever one is most natural for you. I don't care, right? Because I can read them both, so I know what you mean. Okay, I have a page. I'll give you just a minute. Okay, so you can go back to working on the page that you have, and as soon as I find the page that goes with this, it's just a little one-page practice. When you get this page, cross out number 5. It's the ones that go with the word. It's a lot. I think it's. Yeah. What are you talking about? No. No, I don't give homework on Fridays, so it won't be homework. And